This is a training module for the Freescale MCF51CN128 ColdFire Microcontrollers. Welcome to the training module on MCF51CN128 ColdFire Microcontrollers. This training module provides an overview study on the MCF51CN128 series of microcontrollers. The MC51CN Ethernet MCUs are low-cost, low-power, high-performance 32-bit devices designed for developers who want to add Ethernet connectivity to their commercial and industrial applications. Backed by Freescale's extensive development ecosystem, the highly integrated MCF51CN devices combine a 10/100 base T fast Ethernet controller, FEC, and Media Independent Interface, MII, to give developers an easy way to connect an external physical layer, PHY, transceiver. This device also includes a multifunction external bus and multiple communication interfaces for various Ethernet gateway applications. Here list target applications whereby MCF51CN128 can be used. Because of its 10/100 base T capability, half-duplex or full duplex transmission Ethernet features, it finds applications in building control, industrial operator interfaces, medical monitoring, point of sale, and security and building control systems. This figure shows the block diagram of the MCF51CN128 device. It has a Media Independent Interface block external physical layer PHY transceiver, up to 70 general purpose I/O, rapid GPIO, which has special features over general I/O. It also has 10/100 base T fast Ethernet controller block, a DMA block, 12-bit fast ADC block, 2 I2C ports with 100 kilobits per second data rate, and multi-master operation, which is programmable. It has 2 3-channel 16-bit TPM blocks, RTC, which is configurable, TCP/IP communication suite, RTCS. It has Telnet, FTP, HTTP. Other features include 2 SPI interfaces with full duplex or single-wire bidirectional double buffer transmit and receive, and 2 8-bit resolution modulo timers with 8-bit prescaler, and up to 24 KB of static RAM, and up to 128K of flash. Here's the architecture of the V1 ColdFire CPU core. MCF51CN128 series devices contain a version of the V1 ColdFire platform that is optimized for area and low power. The CPU implements the ColdFire instruction set architecture revision C, ISA_C, with a reduced programming model. No hardware support for Mac/eMac and DIV instructions. Upward compatibility with other ColdFire CPUs version 2 through version 5, an integrated multi-master crossbar switch on the ColdFire system buses provides access to system resources by the CPU and Ethernet controller. The CPU configuration register has 1 bit for the control of the crossbar switch. The version 1 ColdFire core is comprised of 2 separate pipelines decoupled by an instruction buffer. The instruction fetch pipeline, IFP, is a 2-stage pipeline for pre-fetching instructions. The pre-fetched instruction stream is then gated into the 2-stage operand execution pipeline, OEP, that decodes the instruction, fetches the required operands, and then executes the required function. Because the IFP and OEP pipelines are decoupled by an instruction buffer serving as a first-in, first-out queue, the IFP is able to prefetch instructions in advance of their actual use by the OEP thereby minimizing time stalled waiting for instructions. Here we show the memory mapping structure of the MCF51CN128. It uses an 8-bit peripheral bus. The bus bridge from the ColdFire system bus to the peripheral bus is capable of serializing 16-bit accesses into two 8-bit accesses and 32-bit access into 4-bit accesses. This can be used to speed access to properly aligned peripheral registers. The TPM is a 1 to 8 channel timer system that supports traditional input capture, output compare, or edge-aligned pulse width modulation on each channel. The central component of the TPM is the 16-bit counter that can operate as a free-running counter or a modulo up-down counter. The TPM counter, when operating in the normal up-counting mode, provides the timing reference for the input capture, output compare, and edge-aligned PWM functions. The timer counter modulo registers, TPM mod H and TPM mod L, control the modulo value of the counter. The values 0 or FFFF effectively make the counter free running. Software can read the counter value at any time without affecting the counting sequence. Any write to either half of the TPM counter resets the counter, regardless of the data value written. The MTIM is a simple 8-bit timer with several software selectable clock sources and a programmable interrupt. The MTIM includes one external signal, T-clock, used to input an external clock when selected as the MTIM clock source. The T-clock input must be synchronized by the bus clock. Also, variations in duty cycle and clock jitter must be accommodated. Therefore, the T-clock signal must be limited to 1/4 of the bus frequency. The T-clock pin can be muxed with a general purpose port pin. The inter-integrated circuit, I²C, provides a method of communication between a number of devices. The interface is designed to operate up to 100 kilobits per second with maximum bus loading and timing. The device is capable of operating at higher baud rates up to a maximum of clock divided by 20 with reduced bus loading. The maximum communication length and the number of devices that can be connected are limited by a maximum bus capacitance of 400 picofarads. Support System Management Bus Specification, SM Bus version 2, and filter registers. The Ethernet Media Access Controller, MAC, supports 10 and 100 megabits per second Ethernet IEEE 802.3 networks. An external transceiver interface and transceiver function are required to complete the interface to the media. The FEC supports 3 different standard MAC PHY physical interfaces for connection to an external Ethernet transceiver. The FEC supports the 10/100 megabit per second MII and the 10 megabit per second only 7-wire interface. The FEC is implemented with a combination of hardware and microcode. The off-chip Ethernet interfaces are compliant with industry and IEEE 802.3 standards. The ADC can perform an analog to digital conversion on any of the software selectable channels in 12-bit and 10-bit mode. The selected channel voltage is converted by a successive approximation algorithm into a 12-bit digital result. In 8-bit mode, the selected channel voltage is converted by a successive approximation algorithm into a 9-bit digital result. When the conversion is completed, the result is placed in the data registers ADCRH and ADCRL. In 10-bit mode, the result is rounded to 10 bits and placed in the data registers ADCRH and ADCRL. In 8-bit mode, The result is rounded to 8 bits and placed in ADC-RL. The conversion complete flag, COCO, is then set and an interrupt is generated if the conversion complete interrupt has been enabled. The ADC module has the capability of automatically comparing the result of the conversion with the contents of its compare registers. The compare function is enabled by setting the ACFE bit and operates with any of the conversion modes and configurations. The Serial Peripheral Interface SPI module provides for full duplex synchronous serial communication between the MCU and peripheral devices. These peripheral devices can include other microcontrollers, analog to digital converters, shift registers, sensors, memories, etc. The SPI runs at a baud rate up to the clock bus divided by 2 in master mode and up to the bus clock divided by 4 in the slave mode. Software can pull the status flags, or SPI operation can be interrupt driven. The SCI allows full duplex asynchronous NRZ serial communication among the MCU and remote devices, including other MCUs. The SCI comprises a baud rate generator, transmitter, and receive block. The transmitter and receiver operate independently, although they use the same baud rate generator. During normal operation, the MCU monitors the status of the SCI, writes the data to be transmitted, and processes received data. It operates in different modes like 8 and 9-bit data modes, stop mode operation, loop mode, and single wire mode. The RTC is composed of a main 8-bit up counter with an 8-bit modulo register, a clock source selector, and a prescaler block with a binary-based and decimal-based selectable values. The module also contains software selectable interrupt logic. After any MCU reset, the counter is stopped and reset to 0. The modulus register is set to 0, and the prescaler is off. The 1 kHz internal oscillator clock is selected as the default clock source. To start the prescaler, write any value other than 0 to the prescaler select bits, RTC PS. The Rapid GPIO module provides a 16-bit general-purpose I/O module directly connected to the processor's high-speed 32-bit local bus. This connection plus support for single-cycle, zero-wait state data transfers allows the RGPIO module to provide improved pin performance when compared to more traditional GPIO modules located on the internal slave peripheral bus. This slide gives you information regarding the development tools available for the MCF51CN device family. The MCF51CN is the first Freescale MCU to be included in the Tower system, a low-cost, reconfigurable evaluation and demonstration platform that speeds time to market and enables advanced development through rapid prototyping. This complete development kit of TWR MCF51CN-KIT provides the basic building blocks for future designs using Freescale microcontrollers.